Okay, picture this. It's Friday afternoon, you're a developer, you've just built your very first multi-agent AI system, and you're feeling pretty good. You test it locally in your notebook, it works flawlessly, so you deploy it, you high-five the team, and you head out for the weekend. But then, Monday morning hits. You log in to an absolute nightmare. Sometime around 2 a.m., one of your agents hit a downstream API timeout, and instead of, gracefully failing, it just entered an infinite loop, silently dropped half its tool calls, and completely drained your API budget while absolutely no one was watching. Sounds terrifying, right? Well, it is. But it's also exactly what we're going to learn how to avoid today. Welcome to today's Explainer. We're laying out a definitive survival guide for developers who are new to AI agents, and we're going to bridge that massive gap between fragile, works-on-my-machine prototypes and actual, resilient, cost-controlled production systems. Here's the roadmap for this explainer. We'll quickly cover the production reality gap, look at a really helpful restaurant kitchen analogy, dive deep into the 4 agent pillars, go over fixing common beginner mistakes, and finish up with your next deployment step.
All right, let's jump right into Section 1, the production reality gap.
There is just a stark, undeniable contrast between your local dev environment and actual production. Over on the left, in development, you have total control. You control the inputs, you're literally watching the print statements roll by, and hey, if something breaks, you just rerun the cell. Super safe. But production, on the right, totally different beast. Out there, your agents are running unattended. They're getting hit with weird, edge case inputs you never even dreamed of testing. And like we said, if a system fails, it can silently drain your budget in minutes. So the big takeaway here is that you absolutely have to design for partial failure. You're not just building a simple chatbot anymore. A multi-agent system needs independent agent recovery. If agent 3 out of 4 goes down, you need a defined fallback, not a total system crash.
Which leads us perfectly into Section 2, the restaurant kitchen analogy.
If you're a developer new to multi-agent architectures, honestly, the best way to understand coordination is to think of a commercial kitchen during a dinner rush. Think of your orchestrator as the head chef. The head chef isn't back there cooking every single dish. They're reading the incoming ticket, they decide which specialized station takes which task, and they check the plate before it goes out. Your agents? Those are the stations. You've got the grill station, the sauté station, the pastry station. Each one has its own specific tools. And here's the kicker. If the grill station runs out of gas, a good kitchen doesn't just burn down. They have a backup plan. Your AI agents need that exact same resilience when an API inevitably fails. I love this summary from our source material. A prototype is cooking for 2 friends at home. Production is Friday night, fully booked, and the orders don't stop coming. When you take your agents out of demo mode, the stakes and the required stability just skyrocket. You aren't just trying to get the right answer anymore, you're trying to survive the rush. So how exactly do we survive that Friday night rush? That brings us to Section 3, the 4 agent pillars. Here they are. Every single reliable agent relies on these 4 load-bearing pillars: reasoning, memory, tools, and guardrails. Listen, if you are new to deploying agents, hear this loud and clear. If you skip even one of these, your system will eventually break under pressure. It is guaranteed. Let's break them down. Number 1 is reasoning. This is basically the brain. It's the layer where the model plans, breaks a big goal into smaller steps, and decides its next action based on what's currently happening. The trick here is matching the model's reasoning power to the actual task. Don't fall into the trap of using a massive, super expensive reasoning model for a basic pattern matching job. Always scope the brain to the task. Pillar 2 is memory. Your agents need short-term context for whatever they're actively doing, plus long-term persistent storage. And this is a massive pitfall for beginners. You have to back this with a real, persistent database. Don't just use in-memory dictionaries that disappear when the script stops. If an agent restarts or hands a task off, it can't just get amnesia. State management has to be rock solid. Pillar 3, tools. These are the concrete actions your agent can actually take in the outside world, making API calls, running queries, executing code, that sort of thing. But here is the critical part. They must be scoped incredibly narrowly to what the job actually requires. A huge mistake is giving every single agent access to every single tool, just in case. If you do that and an agent hallucinates, you've just blown your security blast radius wide open. Like we said with the kitchen analogy, give the grill station a spatula, not the keys to the entire restaurant. And finally, Pillar 4, guardrails. These are your hard limits on cost, steps, and scope, plus validation checks to catch bad outputs before the user ever sees them.
Now, I'll be honest, guardrails are almost always the most skipped pillar because they're the unfun part of coding. But this is literally the only thing stopping that infinite loop from draining your wallet at 2 a.m.
Seriously, check out this expert tip. Before you write a single line of orchestration code, write down your agent's failure budget in plain English. If you don't know exactly what the system is going to do when an agent fails, you aren't ready for real traffic. Period. Doesn't matter how cool the demo is. All right, moving on to section 4, fixing common beginner mistakes. Let's look at how to actually patch the cracks in those pillars. First, no cost ceiling. The fix is simple. Cap your tokens and steps per task. Second, if you have agents sharing some messy, unstructured memory blob, don't do that. Define explicit, structured state that each agent reads and writes to predictably. Third, never, ever deploy straight to 100% of your traffic. Use a staged rollout, watch the traces on a tiny bit of real traffic, and scale up. And lastly, if you don't have timeout limits on your tool calls, go in right now and set explicit max retries. These are simple little configuration tweaks, but they are exactly what prevent catastrophic downstream failures. Which brings us to our final section, your next deployment step. If you're a developer about to launch one of these systems, here is your most actionable directive. Start with one well-scoped agent, just one. Multi-agent systems really reward patience. A single, nicely designed agent with good tools will usually completely outperform 3 poorly coordinated ones. So master the 4 pillars, reasoning, memory, tools, and guardrails on just one agent first. The constraint is actually going to teach you a lot. Only add a second agent when there is a genuine, undeniable reason that the task just cannot be done by one. And I want to leave you with this final, provocative thought before you go off to deploy your next project. Ask yourself right now, if this agent fails, what happens next? If your answer is, I don't know, or, well, the whole system crashes, you need to go back to your 4 pillars. Prioritize resilience over cleverness, and you'll do just fine in production. Thanks for joining me on this explainer, and happy building.